as I started to point out as I went through here, what we've got are nodal planes. We've got planes here in which there is no probability density because there's no wave function. All right? And nodal planes are a consequence of angular nodes. Angular nodes are values of theta and phi that will make the wave function be equal to 0. So radial node is a value of r that makes the wave function be 0. Angular nodes are values of theta and phi that make the wave function be equal to 0. And the consequence of an angular node is that you have an angular plane, that you have a nodal plane. So, for example, in the case of the PZ wave function, when theta is equal to 90, that makes the wave function be 0. And theta equals to 90 corresponds to everywhere on this xy plane. In the case of the px, when phi is equal to 90, if you plug it into your px wave function, you'll find you'll get 0. And when phi is equal to 90, that means everywhere on the yz plane, you have 0 wave function. And same thing here for the py wave function. Phi is equal to 0. That means everywhere on the xz plane, you have the wave function be equal to 0. All right? So these nodal planes, the angular nodes, are consequences of values of theta and phi that make the wave function be 0. All right, now, in general, and this is something you really do have to know. In general, the total number of nodes that a wave function has is always n minus 1. It's given by the principal quantum number minus 1. The number of angular nodes is always given by the angular momentum quantum number, L. So if L is equal to 1, you have a p wave function. You've got one angular node. And so therefore, if L is the number of angular nodes, and n minus 1 is the number of total nodes, and you only have angular and radial nodes, well then n minus 1 minus L is the number of radial nodes. All right? So the only thing you have to remember is L always gives you the number of angular nodes, and you have to remember n minus 1 is the number of total nodes, and then you can always just figure out that n minus 1 minus L is the number of radial nodes. Right? So, for example, here, 2p orbitals, number of total nodes, 1. Number of angular nodes, 1. Number of radial nodes, 0. Okay, you got to know this. And the other thing you have to know is you have to be able to go the other way around. In other words, if I tell you a wave function has so many angular nodes and so many radial nodes, tell me what the possible wave functions are. Okay? So you got to be able to go both ways here on this.